Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x plus 2 times x plus 9. We're looking for two numbers that multiply to give you 18 and add to give you 11. So those are the two numbers you would use. For the math knowledge question, it asked for what was the total number of miles in her round trip. She drove to work at an average speed of 40 miles per hour and then returned along the same route at 30 miles per hour. So she went somewhere and then she came right back. And the total time was 1 hour. So hopefully y'all have seen distance equals rate times time before. D equals RT. So we know that the distance there has to equal the distance on the way back. So the rate times the time on the way there is going to have to equal the rate times the time on the way back. So I'm going to say RT there is going to equal R times T on the way back. So the rate that she went there was 40. And then the rate on the way back was 30. The total time was 1 hour. So the time there plus the time going back has to equal 1. And so I can either plug in T sub T or T sub B. So I'll leave it as T sub T. So that means that T sub B would be 1 minus T sub T. So that's what we can plug in here for T sub B. So 1 minus T sub T. And then you distribute. And then I'm going to add this over. So that'll be 70 T sub T. And then divide by 70. So the time there was 3/7. So it asked for the total number of miles, and that's the time. She took 3/7 of an hour to get there, and she went at 40 miles per hour. So the distance is going to be the 40 times the 3/7. So that's 120/7, which is 17 1/7. But that's just there. It asks for the total number of miles. So going there was 17 1/7, and then going back was 17 1/7. So 2 times that would be 34 2/7. So that would be your answer. Okay, so if you're not comfortable working through a problem like that, don't worry. We will get there, especially once you take Algebra 2. For those of you that have not taken Algebra 2, it'll definitely get more comfortable. We'll have more problems that we practice like that. So if you weren't able to get that one, y'all can pause the video and y'all can rework it a different way. You can let your neighbor explain it to you. If you got the right answer, then you don't necessarily have to do it the way that I worked it. That's just one way to do it. So don't stress about it if you don't like all of the variables and all the equations that I made. It's okay. I know that it will take you some practice to get that right, and that's perfectly fine. This is something for helping you with the ACT. This isn't on our geometry test right now. Alright, so we're looking at lesson 6 today. We're looking at identifying pairs of angles. So hopefully after this lesson you will understand about complementary angles, supplementary angles, adjacent angles, linear pair, vertical angles, and you'll be able to go over problems that deal with those as well. So we're looking at complementary angles first. Complementary angles are two angles that add up to 90 degrees. So this is a 90-degree angle over here. This is a 90-degree angle over here. So A plus B add up to 90, and so that means that A and B are complementary. So since A plus B equals 90, these two are complementary. Supplementary angles are two angles who add up to 180. So C plus D are going to equal 180, and so that means that C and D are supplementary. You need to make sure to learn the difference between complementary and supplementary. Complementary is 90, supplementary is 180. Okay, so let's look at an example. We want to find the angles that are complementary to angle KLM. So KLM, and it says if KLN is 90 degrees. So KLN is 90 degrees. And we want to know what angle is complementary, or angles are complementary to angle KLM. So this angle right here. So if this is a right angle, that means that these two angles have to be complementary. So the angle that's complementary to KLM would have to be this one here, which would be angle MLN. Okay? However, if you look, they also told us that this is a right angle. And so that means that these two angles are 90 degrees. So this angle and angle JLK are also complementary because they both add up to 90 degrees. So both of these angles are complementary to angle KLM. Looking at the angle supplementary to angle DGF. So we're looking at this angle here. We need to make a straight line basically whenever we have supplementary angles. So the other part of the straight line would be right here. So angle EGD would be supplementary to angle DGF. But also, there's another angle that is supplementary to this one right here. This angle here would make a straight line as well. So angle CDF is also supplementary to the angle they asked us to find. So both of those are supplementary to this DGF angle. Okay, we're going to look at theorem 6.1, congruent complements theorem. If you have two angles that are complementary to the same angle or congruent angles, then they are congruent. So we just did that on the first example. These two were both complementary to this angle here. So what that means is this angle here and this angle are going to have to be congruent because they both are complementary to this middle angle. That's what that is stating. So I'm going to draw it again. So if this angle is 60 and this is the right angle, that means that this one is 30. And if these are a right angle, that means that this one would have to be 30. And so that's how these two are both congruent. Theorem 6.2 is the congruent supplements theorem. It tells you if you have two angles that are supplementary to the same angle or congruent angles, then they are congruent. So if you go back to that first example here, if this angle was 40 degrees, that means that this one had to be 140 because they are supplementary to each other. They have to add up to 180. And likewise, this one also has to be 140 because they're supplementary to each other. And so this angle and this angle are congruent to each other. So that's what the congruent supplements theorem is saying. So let's look at example 2. We want to find the measures of the angles labeled X and Y. So if y'all think y'all can do this one by yourself, go for it, and then I'll unpause the video and I'll go over it. So you're going to want to start by finding X. This angle right here is a 90-degree angle. And so if this is 55 degrees and this is X, that means that 55 plus X has to equal 90 degrees. So if you solve for X, X would have to equal 35 degrees. Okay, and then we know that all 4 of these together make a straight line. So that means that Y plus 55 degrees plus X, which we just found to be 35, plus 40 has to equal 180 degrees. And so if you solve that equation, Y plus 55 plus 35 plus 40 is 130. And then if you subtract, Y will equal 50 degrees. And so that would be your X and your Y. Okay, so let's look at pairs of angles. Adjacent angles are 2 angles that are in the same plane that share a vertex and a side, but they share no interior points. Let me draw a picture of that real quick, just in case. Adjacent angles are like neighboring angles. This angle here and this angle are adjacent. They're sharing a vertex and they share this side, but they don't have anything that overlaps. Linear pairs are adjacent angles whose non-common sides are opposite rays. So looking at this picture, RST and TSM, if you put them together, those are adjacent angles and they're non-common sides. So this is the common one. This would be the uncommon sides, are opposite rays. Basically, a linear pair, they have to equal 180. So when you put the 2 angles together, they make 180 degrees. And then vertical angles are going to be angles that are opposite of each other. So angle A and B are vertical angles, and angles C and D are vertical angles. They are across from each other. Vertical angles are always congruent to each other. So if this is 30 degrees, then angle B is also 30 degrees. And if angle C is 150, then angle D has to be 150. Looking at theorem 6.3. If the 2 angles form a linear pair, then they are supplementary. And I just mentioned that whenever I said the definition for linear pairs. So this is called the linear pair theorem. If you have a linear pair, then you have supplementary angles. However, just because 2 angles are supplementary does not mean that they are a linear pair. Let's say I take this angle and this one, and together they equal 180. Those angles are not a linear pair because they're not adjacent to each other. So just because you have 2 angles that are supplementary doesn't make them a linear pair. Looking at another example, we want to identify 2 sets of adjacent angles and 1 linear pair. So there are a ton of options that you could pick here. So I'm going to name just a couple of them. For the adjacent angles, you could do angle AFB and angle BFC, for instance. AFB and BFC. You could also do angle AFB and angle BFD. This angle and this angle are still adjacent to each other. we could also do angle AFB and angle DFE. Not DFE, sorry, BFE. So this angle and this angle are adjacent to each other. And this one is also a linear pair. So that would be enough for what they asked for. Another linear pair would be angle AFC and angle CFE. So AFC and CFE, together they make a straight line. But you have a lot of options here, and I'm not going to go through all of them, but if y'all need to pause the video and check with someone to see if your angles work, you can do that. Theorem 6.4 is the vertical angle theorem, and it says if you have two angles that are vertical angles, then they are congruent. And that's what I already said when we went over vertical angles. This is just a theorem stating that fact. We want to determine the values of x and y. So we have vertical angles here. This angle and this angle are vertical. So that means that they are congruent to each other. So 2x minus 5 is going to equal x plus 3. So if you solve for x, we can subtract x here. And so 2x minus x is x. And then you can add 5 to get that x equals 35. Okay? For y, vertical angles are congruent. So these two angles are congruent. So y plus 17 has to equal 2y minus 81. So if I subtract y from both sides, I get 17 equals y minus 81. And then if I add 81 to both sides to get y by itself, I get that y equals 98 degrees. Okay. So now let's look at another example. We have a diagram that shows part of a bridge, and it says that the bridge and the cliff are perpendicular. And you may not be able to tell it in the picture, but there's a little bitty right angle right here. And it says this is a 50-degree angle, and we want to know what x would be. So I'm going to draw some lines in red to help you see them a little bit. We've got this angle here, line here, and this line here. So how is this 50 degrees and this y degrees, how are they related? They are vertical, so that means that 50 and y have to equal each other. And then also, if this is a right angle, we can draw a line here, and that means that these two would have to be a right angle as well. So x plus y would have to equal 90 degrees. And they told us enough information that we know that y equals 50. And so if you solve for x, x would equal 40 degrees. So that would be your answer for that one. Okay, so now we're going to look at some practice problems. So y'all try these by yourself and then unpause the video and I'll go over the correct answers. So the angle that is complementary to PKM is going to be the other angle that makes up the right angle, which is this one here, angle MKN. And then which angle is supplementary to JKL? So we need to make a 180 degree angle. So that's going to be LKN. That's the one that's supplementary. You cannot have another option other than NKM or NKL. One of these two for A and one of these two for B. No other option would work. For the third one, these two are a linear pair, and so that means they add up to 180. So 3x plus 10 plus 2x plus 5 has to equal 180. So if we add over here on the left side, we get 5x plus 15 equals 180. So then we can subtract 15. So 5x would equal 165. And if you divided 165 by 5, x would equal 33 degrees. So that would be your answer for those three. Okay, let's look at these two. Again, y'all pause the video and try them by yourself. And then unpause the video and I'll go over them. So I'm just going to pick 3 pairs of adjacent angles and 2 linear pairs. You may have different ones, and that's fine. Y'all can go over them if you don't have what I have to make sure that you understand it. So this angle here and that angle would be adjacent. HKL and LKM. Another one would be JKI and angle IKM. This should be a K here. HKL and LKM, those are adjacent. And then JKI and IKM, those are adjacent. So those are 3 examples. There are lots of them. So you may not have those, you probably don't have those as your answers, but maybe you have one of those pairs. For linear pairs, angle JKN and angle NKL would make a linear pair. This angle and that angle make a straight line. Also, angle MKI and angle IKN. So MKI is here, and then IKN is here, and together they make the straight line. So those are 2 linear pairs, but again, there are several that would work. For this one, these are vertical angles. So 6x minus 13 would equal 3x plus 11. So then you're just going to solve your equation. So I'm going to subtract 3x on both sides. And then I'm going to add 13. So 11 plus 13 is 24. And then if you divide by 3, x would have to be 8. So that would be your answer there. For this next one, again, y'all try it, and then I'll go over the correct answer. So it says we have a roof that has 4 triangle sections, and it puts it over here for you. And it wants to know the value of x, and then angles 1 and 2. So if I make these lines, this angle here is 40 degrees, and this angle is 2x plus 30. And together they have to equal 180 because they're a linear pair. So 40 plus 2x plus 30 would have to equal 180. So then combine your like terms over on the left side. 2x plus 70 would equal 180. And then subtract 70, you would have 2x equals 110. And then if you divide it by 2, x would equal 55. So that's your x value. Then it asks for the measure of angle 1. So angle 1 is going to equal whatever this is over here. So 2 times 55 is 110, and 110 plus 30 is 140. And then over here, angle 2 has to equal 40 degrees because they're vertical. So angle 2 would equal 40 degrees. So that's the answer for the last question. Okay? So hopefully you were able to get most of those practice problems right by yourself. We're going to look at our challenge question now. Y'all read through this and pause the video and try it by yourself, and then unpause it and I'll go over it. So angle A and B are a pair of complementary angles, and C and D are another pair of complementary angles. What can be made about A and C if B and D are a pair of complementary angles? That means that A and C are also going to be a pair of complementary angles. So I'm going to draw this is angle A, and this is angle B, and this is angle C, and this is angle D. So these are a right angle, and these are a right angle. And then they also tell us that BD has to be a right angle. So that means that this one and this one are also going to be a right angle, because all four of these have to add up to 180 degrees, and two of them equals 90, so the other two have to equal 90 as well. So that's the answer for the challenge question. A and C are also going to be complementary angles. All right, so your homework is 1 through 30, so make sure that y'all do those tonight so we can go over any questions you have tomorrow.